Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Before we introduce today's guest, let me tell you a little bit about the show. We founded the concept of Data Unchained around what are the aspirational things you could do with your data if it could move anywhere, be generated anywhere, and be utilized anywhere. And as we delve into this podcast, we talk about some of the challenges as data has become increasingly decentralized, moving from the days when data was generated in a mainframe and the storage, the applications, the humans were all local to that data, to now data is created in devices and space, pretty much everywhere we can think about, and is being used by applications and humans that weren't really intended to be the users when that data was generated. Thinking about loading historical scientific research data from a supercomputer into an AI model, for example. So there's a lot of new use cases that are really exciting. In this podcast, we delve into some of the challenges, the opportunities, and the technologies behind this trend. So without further ado, I'm going to introduce today's guest. We have Chris Mellor joining today. He is the storage writer for Blocks and Files, which is owned by the same company as the Register. Chris, welcome to the show.
Thank you, Molly. It's a pleasure being here.
Before we talk about technology and storage, tell us a little bit about your background and how you came to being a storage writer.
Okie dokie. I started working in the industry in mainframe times, writing job control language code, moved on to Fortran and other stuff as well. But it rapidly became apparent that I was far better at explaining messages about how computing systems worked than actually implementing them or managing other people to implement them or doing anything else in the traditional corporate world. So I moved into journalism. And data storage just seemed to me to be one of the key aspects of the whole IT industry. If you don't store your data properly, you can't process anything at all. And so Blocks and Files was started up to look at originally mainly blocks and file protocol data. Then objects came along, but Blocks and Files is a neat phrase. Adding objects to it just makes it clumsy, so we just forget about that and just call it Blocks and Files. And I've been in the industry for, it seems like forever, 30 years or more, and seen a lot going on. And the fun thing is that right now, it's really, really exciting because of AI, because of what Western Digital is doing with disk drives, and because of the whole SSD and high bandwidth memory type side of things. AI is wonderful for the industry.
Yeah, it's been fascinating to watch the innovation that's occurring both from the technology providers as well as the customers, hasn't it, on what they're doing with AI and how quickly it's advancing.
It has. One of the fun things about it is that an AI agent or an AI model, the more data it looks at, the better its responses, its results are going to be. And that's encouraged everybody to start thinking about how we can put all our data from its different sources into one place so that an AI model or agent can look at it and work on it simply, rather than having, say, different pipelines from different sources to the data.
So you hear a lot of different angles on how to put stuff into one place, putting data into one place, as you talk to different vendors and, integrators who are approaching this. Is it the approach that people take all that data, let's say generated over the last 30 years of an enterprise, and do move it all to one cloud instance next to a model or a storage system in the data center next to a model? Are humans moving it to one place? Is it a logical thing where you try to aggregate it logically but not physically move it? What do you think people are looking at doing when they say put all the data in one place?
I think people are looking at the idea of having one silo for data, but rapidly walking away from having one physical silo for the data because it's too difficult. You can't take all your decades of structured database information and put it in the same physical space as decades of file information and decades of object information. You have to, in some way, have a virtual silo. And I think people are beginning to realize they're going to progressively move the data from the sources into this silo and then make it vectorize it, transform it into a way that's suitable for AI agents and models to look at.
And we weren't really planning to talk about this when we chatted about the show beforehand, but I did want to talk, since you brought up vectorization. To you, is that just a new translation layer of data? So now is it blocks, files, objects, and vectors? Or how do you think about vectors?
I think that's absolutely a fascinating subject. Many object stores are basically key value stores underneath. So you have the actual data item, and then you give it a key. And keys are listed in some ordered space so that they can be found. Well, vectors are best stored, I think, in a key value store. So in a way, there's a natural fit between vectors and objects. But vectors have their own particular characteristics. And one is that they're vast. An object bucket can create massive amounts of vector data because each item in the object, its vectors can apply to many, many dimensions of the object. So you could have, say, a terabyte of object data, and it could generate 5, 20 terabytes of vector data, depending upon how many dimensions you look at. I think it's crazy. So how people are going to cope with this in the future, Lord alone knows. Because the vectors have got to be stored somewhere so that you can use them again in the future rather than recomputing them. And they've also got to be stored somewhere that's very, very active so that when you're actually doing an AI analysis, you don't have to recompute the vectors that have overflowed from your memory of the GPUs involved in it. The key value caching of vectors is becoming a crucial part of all this.
And all of this that we've talked about so far has led to something of a crisis in our industry of the access to NAND-based technology, whether it's some of the memory, the solid-state storage, is in really limited supply. I think it would be a nice segue talking about, the idea of AI has been so exciting. And we talked for the last year about, my goodness, how do I get access to GPUs? How do I buy them? How do I use them in the cloud? And we weren't watching as an industry so closely, how do we manage the storage situation? The aggregating the data, more data being generated by AI. Can you just give us a summary of what you see as the pain point in storage right now related to access to SSDs?
Once an AI agent or model is working, it's got to process vectors that are held in the GPU's high bandwidth memory. It's got limited capacity. So that high bandwidth memory has got to be fed from something. And typically it's fed from a fast SSD store. And the closer you can get that SSD store to the memory, the better. So that's one area that's having a lot of activity worked on it. The other is that those SSDs are now in a limited supply because there's so much emphasis by organizations, the hyperscalers and large enterprises, on using the SSDs to hold data close to their GPU accelerators for training and also for inference. The demand for SSDs has absolutely rocketed up, and the SSD suppliers simply can't make enough of this stuff. So that we're in a shortage. Prices have rocketed up. SSD suppliers are, in some cases, contracted out for their output for the whole of next year. And since it takes so very, very long to build an SSD fab, like 3 years or more, we're not going to see more real fab capacity come on stream until late 2027, 2028. The existing clean rooms can maybe optimize so you get some more fab capacity that way. But you really need to build more fabs. And this is so vastly expensive. We're talking $10, $20 billion or more per fab, that the suppliers won't commit to building them unless they see 5 to 10 years consistent demand ahead for the output. And I don't think they can see that yet. They're beginning to. So we're having new fabs commissioned and so forth, but it's going to take 2-3 years before we see any significant increase in SSD capacity, and we're going to be in a shortage until then.
So how bad is it? Is it, if I were Fortune 500 enterprise and wanted to go buy 10 terabytes of SSDs for my next AI project, do you believe they can get them this year? Or are they really having to look at some other architectural way to accomplish this?
It's hard to say. They'll be getting them from some suppliers. probably some kind of intermediate supplier between the actual NAND fabricator like SK Hynix or Micron or Samsung and themselves, some kind of system house, a sophisticated reseller in between. They'll have an inventory. They'll also have supply arrangements, which could be long-term with the fabricators. So the larger their inventory and the better their long-term supply arrangement, the more consistent their supply can be. But if you're going to pop into the market now, phone somebody up out of the blue and say, can I have 10 terabytes of SSDs? They'll say, thank you very much. You're going to pay 50% more than you did 2 months ago. And by the way, you're probably going to have to wait 3 months for the actual delivery or longer. And I think the situation is going to get worse.
As we think about how we can guide some of these users who are looking at options, certainly getting your orders and your demand in sooner is step number one. Indicate your need for sure. Architecturally, do you see other options rather than just buying SSDs that will help them keep their AI initiative, or even if it's not AI, their storage initiative rolling if they can't get access to SSDs in the time frame they need for their project, or by their own at least?
Yeah, I think there are two common sense ideas that organizations have to apply. One is to make the absolute best use they can of their existing SSD capacity. So if there's data being stored in SSDs which shouldn't really be there because it's not critical, then move it off. Just move it someplace else. Logically, again, there are only two places, disk or tape. I mean, it's disk or tape, whether it's on premises or in the cloud. The medias are going to be the same. The other thing they need to do, I think, is start thinking about caching more. Caching is an absolutely classic response to a shortage of fast storage or fast memory. You cache a slower layer of media beforehand. So start thinking about sophisticated ways of caching hard disk drive data so you can then feed your limited SSD capacity and keep that going.
And when you think about using your SSD capacity efficiently, certainly tearing off of it, only using it when you need to is important. Compression, deduplication, data reduction technologies certainly are things to take a look at as well.
Absolutely, yes. Sorry, absolutely. It sounds like a cliche. But yes, if you can get another 5 or 10% or even more effective capacity by deduplicating data that goes into SSDs, then hooray, you've done yourself a great favor. And the value of that extra capacity is shooting up month by month as SSD costs rise. So I think that gives people an interesting comparison they can make. They can compare the cost of their saved capacity against the price of software that may be needed to save that capacity. And whereas before it might be that you'd spend, figures out of thin air here, you're spending, say, $1,000 to save $200 of SSD capacity. Now you'll be spending $1,000 to save $2,000 of SSD capacity. That suddenly makes the software acquisition price much more acceptable.
Absolutely. And it is interesting that I think people have gotten accustomed to quoting their storage and their software together, that's kind of one project in one package. And now that they're going to be considering, I can't get any hardware, I'm going to have to buy just software to better take advantage of the hardware I have, that will create some interesting pricing conversations. How do you, in procurement, buy software without hardware? Because that's not how people have bought it in the past, really. So I think there's some shifts. And, I work for a vendor and I see this right now, that the old way of doing things that was the path of least resistance, everyone knew would work, is now starting to shift because there's a forcing function here with the hard drive and SSD shortage that's occurring. Do you see software enabling more kind of hybrid cloud workflows that people will go back to the cloud for reasons they weren't in the past?
That could well be the case. Because if you're limited in your own SSD capacity, but you can rent capacity quite readily from Amazon or Azure or Google, then that starts looking to be an attractive option. Why not go and use some of that capacity instead and have your models and agents look at data there rather than on your on-premises hardware? Forgive me, I think there's another aspect here, which is that with tiering of data, how do you detect which data's tier and which not? Well, classically, it's by looking at the data's access patterns, say, over the last 3 months, who's accessed these files and who's not, and so forth. I don't think that's good enough anymore. I think you're going to have to dynamically tier, and I think you're going to have to look at access patterns for data in shorter periods than months, so you can move data in and out of the tiers far more quickly and far more responsively. You better respond to situations then.
Absolutely. And I think one of the great tools for that is enriched, very robust metadata. So you have good information about what is the data, how might one set of data be used at the same time as another data. So it can be machines moving the data in and out versus a human decision.
I think you're absolutely right. The more metadata you have about how your files and objects are being used in your limited SSD capacity, the better. Because then you can use that to switch the files and objects back and forth between the SSDs and a disk drive backing store much more quickly, much more effectively. So you could have short spikes in activity which you can respond to quite quickly and effectively, whereas before, with say, a manual or a 3 months check on data access rates, they're invisible to you. Your granularity of access becomes much finer.
So let's consider a situation where you're using the cloud for this kind of temporary capacity to get yourself through this shortage. You have data moving in and out based on, some intelligence so that you have the right data in the right tier. Have you spoken to the cloud vendors recently about how they're approaching this? Will there be massive ingress and egress if you're doing this? Are they offering different storage options to help get through this crisis, or have they not really publicly responded to this in any way yet?
My opinion is that the public cloud vendors haven't responded to this crisis yet. I think they're very measured in how they produce different storage tiers. So it will be months between different levels of storage tiering being introduced by them. They're not fast-moving organizations. If they were, we would have seen some kind of short-term offering from either Amazon or one of the others about back up your limited SSD capacity by using the stuff we've got in our cloud. And we're not seeing that at all. I don't think they're fast-moving organizations, which says to me there's an opportunity for some software or service supplier sitting between them and enterprises to arbitrate between the different public clouds and what they're offering, and suggesting moving data and positioning it in the different clouds and the different cloud regions to suit what your own needs are.
Yeah, absolutely. That's an interesting idea. And if they could arbitrage that and help the customers figure out not just which storage offerings there are, but how does that map to their needs for compute and upstream models and whatnot, that'd be a huge value add as customers are navigating this situation. Have you heard what the pricing differences are right now? On SSDs, I think the latest quotes I've seen is 2 years ago or so, we were selling at 5 cents a gig, and now we're at, or at least can, as vendors acquire them, for about 20 cents a gig. Is that about what you're hearing on the pricing, a kind of a 5x increase versus a few years ago?
Oh, yes, and possibly more. If I could mention one vendor here, it's Vdura. They have a pricing calculator on its website, and that uses real-time SSD pricing compared to disk pricing. Of course, Vdura has a stake in this because they offer hybrid storage. So they actually want to say that a combination of flash and disk drives is equal to or better than an all-flash competitor. So hence they put up this pricing comparison or pricing generating facility on their website. It's a good place to look.
And on the hard drives, we spoke about the value of using hard drives already, and that it's very logical to put them into place. I believe pricing on hard drives has also gone up about 3x is what I've heard in the industry so far. Is it because of a shortage, or is it just all of a sudden they see a spike in demand and they're responding that there's a premium price that they can ask for their technology?
We're not benefiting from there being an oligopoly in the disk drive industry. Two main suppliers, Western Digital and Seagate, they've both turned into businesses that deliver returns to their shareholders. They're cash flow driven businesses. They're shareholder value driven businesses. And a disk drive manufacturing facility represents to them an enormous cost. They're simply not going to build another one with the $10 or $20 billion involved in that, unless they can see a clear path to giving even more money back to their shareholders and getting more revenues over the long term. So we've got limited disk drive capacity at the same time as the AI boom is generating more and more data needing to be stored, a shortage of SSDs, and basically, where are you going to go? If you can't store it in SSD, you have to store it on disk drives. The disk drive manufacturers have also concentrated on a single disk drive class, nearline storage, mass capacity drives spinning at 7,200 RPM. That's what they make. They have no scope for making any other type of disk drive, and literally, being blunt, no interest. I'm having a fine time. I can sell my disk drives now for 3 or 4 times more per terabyte than I did 5 years ago. My shareholders are happy. My factories are full up. I've got long-term contracts lasting years. Why should I do anything? Nobody's threatening me. And Western Digital and Seagate have been happily doing this for the past 2 or 3 years. I think things are about to change because Western Digital got spun off, or rather, it spun off its solid-state drive operation, SanDisk, and is now just a disk drive operation. And they've been talking to the hyperscalers and saying, how can we make our disk drives more attractive to you than, say, Seagate or QLC SSD drives, which people are saying you use for fast nearline storage. And the hyperscalers are saying, well, your disk drives are too slow to give us information. The I/O density, the ratio between the bandwidth we can get information off and the capacity of the disk drives has been worsening over the past decade or more. What can you do about that? You've got, they say, 10 to 11 platters in your disks and read-write heads per platter, and you only read from one read-write head at a time. Why is that? These things are inherently parallel. Why can't you? Oh, said Western Digital engineers when asked. Well, we could do that. Of course we could do that. And so it's coming out with this high bandwidth disk drive, which will simply double disk drive's I/O capacity. Well, you can do it too. You can read from 4 heads at the same time, 6. They're seeing a way to double, quadruple, and go beyond disk drive I/O capacity. Well, that suddenly changes the relationship between disk drives and QLC SSDs, because you're going to have disk drives pumping out data at 500 or 1,000 megabytes a second, just like QLC SSDs do. I think the disk drive industry is about to undergo a renaissance because of this. Hey, I'm flying a kite here, Molly. Forgive me.
No, I mean, it's fascinating to hear how vendors are responding to the new workload needs. And I/O is such a big deal. I mean, I think about last year, 2 years ago, all we could talk about was power. Power is an issue. Everyone was thinking about how do I get enough power for my GPUs? And so I need my storage to be power efficient. I need my infrastructure across the board to be power efficient. And that's an issue. And we're, as an industry, still figuring out how to deliver power. But then when you get your technology in, if it's not fast enough for the GPUs, that doesn't work either. You know, it's kind of a chicken and egg situation that the most power efficient things sometimes aren't as fast. And sometimes the, most power efficient things now aren't even available with the SSD crisis. So vendors have to respond. And how vendors are thinking about meeting this, trifecta of needs, cost, power, availability that customers are really struggling with is really interesting topic. Are you seeing tape come into the conversation? Are people now thinking, well, maybe I need to use my tape in a more active AI environment?
That's a great question. However, like hard disk drives, tape is absolutely stymied by its I/O rate. And it's slow. It is slow. It's inherently slow. It's a sequential access media. It's not a random access media. And the dratted things are stored in shells, and they have to be fetched by a robot to brought to the drive. What a disk drive is a drive itself, so it's inherently faster. I think tape for any form of active data storage is just not on. I mean, we have the Active Archive Alliance, but that's active in quotes. When we're talking about active data storage, we'd like it off the device, please, in milliseconds at least, not longer than that.
Yeah, a day is a bit too long for sure. And, and I do have conversations with the tape vendors about a topic you talked about earlier of could you accomplish some sort of intelligent caching where you can proactively know a job is going to run or a model is going to be trained and get the data off tape in advance to something faster. And there could be some interesting innovation there, but it takes a lot of knowledge about your data to do that. To proactively, before the job is running, know what to hydrate into a faster store.
With disk drives, we have an oligopoly between Western Digital and Seagate. With tape drives, the drive, as a single supplier, IBM, it has a monopoly. Nobody's threatening IBM as a tape drive supplier. It can sit there, fat and happy, and do an incremental advance every couple of years or 3 years or so, and that's that. And nobody can do a thing about it. It drives people in the tape library industry absolutely crazy that they're dependent upon IBM for this. But there we go. That's the way it is. One thing about increasing I/O from disk drives is that the ratio of capacity between your SSD capacity and your cache disk drives, you can put more on the cache disk drives because you can get the data from them to the SSDs faster as soon as you've got high bandwidth drives. And I think they'll be coming out tail end of this year, maybe early next year, 2027.
And where do you see high bandwidth memory coming into this? That's an interesting newer topic. And I kind of just swung the pendulum from tape to memory on when you're thinking about performance. But as we're looking into the future, will that be a part of the solution or at least part of the architecture people are considering?
Putting data into high bandwidth memory or whatever memory is attached to GPUs is the responsibility of GPU software and the GPU system. But that high bandwidth memory has to be fed. And it's fed from SSDs. If you could get that SSD capacity closer to the GPUs, then the storage suppliers could pump data into that SSD capacity. Now, it may sound like I'm going around in circles here, but I'm talking about the concept of high bandwidth flash. High bandwidth memory is stacks of DRAM layered above an interposer unit which communicates to the GPU very, very closely. We're talking millimeters or less distance between the two. You could do the same with flash. You could have layers of flash stacked above an interposer also talking to the GPU, or rather talking to the high bandwidth memory, which then talks to the GPU. And suddenly the high bandwidth flash becomes a very, very high capacity cache for SSD data right next to the GPU. Well, suppliers who tier data between disk drives and flash could, in theory, then tier that data to high bandwidth flash as well, given the right software from NVIDIA or AMD to actually move it into the high bandwidth flash. It's a topic, I think, that SSD suppliers like SK Hynix and Samsung and SanDisk are increasingly focused on. But until NVIDIA or AMD comes out publicly and says we're going to design this stuff into our GPU systems, it's got a question mark over it. So the NAND suppliers can be happily pushing away at this, but they have one route to market, and that's through NVIDIA or through AMD. And those two gatekeepers have to say, yep, we'll use it. It's a big decision for them.
Absolutely. And I think GTC each year is a interesting time frame. A lot of announcements occur both from NVIDIA as well as all the suppliers who work with NVIDIA. At Hammerspace, we're working on our AI data platform, which is not a new announcement. That's something that customers are aware of as a program from 12 months ago from NVIDIA. But that's a good example of NVIDIA working on bringing this together, putting into a single box that you can buy some GPU, some NVIDIA software, some storage software that's aware of the data, the KV cache and all that. And it seems like that's where they're trying to get to. No one can really predict what NVIDIA will do next, but there are definitely programs in place where they're trying to simplify for the customer. How do you get the NVIDIA tooling and software, the NVIDIA hardware, the memory, a bit of storage, and the storage software where you could actually buy a system and do this all in one. And I think that indicates that they're thinking about this direction for sure.
I'm sure you're right. NVIDIA has spent a lot of time over the past 5 years or so working out how to get data from storage media into its GPUs faster. So we had the GPU direct idea, cut out hops between the storage media, local processors, and the GPUs. NVIDIA knows that memory is a profound problem for its GPUs. Agents and large language models are getting larger and larger in terms of the parameters, the tokens they use, and memory is simply not enough. So it's now devoting a lot of attention to the KV caching idea and somehow using a KV cache which includes SSDs as well as the high bandwidth memory. And that means it's had to work with software suppliers such as your own supplier, Vast Data, Pure, da-da. What's really, really interesting to me is that SK Hynix, one of the main NAND suppliers, is now opening up an AI subsidiary in the USA. It's setting up this subsidiary with several $1 billion of investment capital behind it, parking it on top of Solidigm, the Intel-acquired NAND builder, and saying it's going to invest in the AI ecosystem. Well, obviously, it's going to invest in that ecosystem so that its own products get used by it. But how is it going to invest in that ecosystem? It's got to go up stack. It's got to go up to software vendors. I think we're in for an absolutely fascinating time.
Absolutely. So as we tie up, I want to tie back to the conversation about the SSD and NAND shortage that we started with. How do you see this year playing out? Will AI initiatives be slowed down? Will people be forced to architect differently, perhaps more efficiently? Kind of how do you see this playing out for the next 12 months?
I think people are going to have to start using different AI models. By that I mean different AI model suppliers, because the suppliers have relationships with the main public clouds, with neo clouds and so forth, each of which have their own capacity. I think people are going to be hunting for AI model execution capacity. So rather than saying, well, we would do all our work with CoreWeave or we're a total Google house, they'll have to shop around to find the capacity they need. Because I think that AI inferencing is going to is going to noisily take off more and more and more. The models are good enough. The agents are beginning to look good enough for it to happen more and more. And I think enterprises, they're going to have a severe fear of missing out. They're going to feel that if my competitor down the road is using these AI models to help out its customer service, well, then by golly, we better do the same. If my competitor down the road is evaluating insurance claims using AI, then by golly, we better do the same. It's going to become almost like a tick list item. You have to do this stuff now. And even if the apparent return on our investment from an AI project are hard to justify, I think that fear of missing out will overcome that. I also think people will get better at judging the return on investment of an AI project. The old off-quoted MIT study, I think, is just going to be ignored. It's going to be thrown away as being inadequate.
Chris, this has been a great episode, rich with a lot of information. I want to point the listeners who potentially don't follow you today back to Blocks and Files. Chris writes a lot, and as these trends evolve through the year, I'm certain you'll see him writing on them. So he's a fun morning read for those of you who are listening that don't have him on your watch list. And as some of these trends and new technologies as well as approaches evolve, I'm certain that he'll be writing on. So I definitely recommend you follow Chris. And thank you so much for joining the show, Chris. It's been a pleasure.
Molly, it's wonderful. I don't often get the opportunity to just talk and talk and talk. And this has been a lovely opportunity to do that. I think the industry is absolutely fascinating. I learned so much from talking to suppliers and about technologies and so on. It's a wonderful place to be at the moment. Thank you very much.
It is. Have a good evening. Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.